This is Module 13, Lesson 2. Obviously, we're going to talk about water today. Water is a very important substance for life, hence why we're giving it, a good bit of attention. You're expected to know a lot of these things if you're going to take like an AP Bio or an AP Environmental class, so another reason for doing these things. Let me also mention, before you get going, that this is a very good lesson, as are the next couple of lessons, if you would like to get ahead. These are pretty short, the videos are pretty simple, there's not a whole lot to do, it's mostly concepts, so if you would like to work ahead, now's a good time. So, of course, first the liquid state of water. Take a minute to copy down what's on this slide so that you could study it later, and then you can come back for some conversation. So, of course, one of the things that I want to point out about water is that it has a very high surface tension. If you've ever noticed that bugs can walk on water, or, not that you really sit around with your time and look at puddles, but if you have a flat surface here, and you would pour out like rubbing alcohol onto the surface here, it makes a very flat puddle. Whereas if you pour water, it actually makes a pretty good dome. It makes a bead or a droplet, and you could put a whole lot more drops of water in a little puddle here before it would flatten out than you could something like alcohol, because it has such a high surface tension. Why does that matter, you may be wondering? Well, it helps out with some of the things on the next slide, for one. It gives it, it makes it bond to itself, and so because of its surface tension, it allows things to walk on top of it. It also helps out with this vapor pressure. Water has a very low vapor pressure because the water molecules are attached to themselves, so it makes it harder for them to escape and evaporate. Now, if it weren't so low and you walked outside on a hot summer day when it's 100 degrees Fahrenheit, or even in the 90s, and you were outside in the sun for a long time, you would dry out very easily as a living being. And so it's very good for you that it has such a high surface tension and therefore low vapor pressure. Okay, now water in the solid state. Ice is also pretty unique because it floats in its own liquid, which, for us, most of what you have experience with in life is things that are water-based. I don't care if it's frozen orange juice, frozen soda, but most everything that you come into contact with that's a solution is a water-based solution. And so you and I don't experience a lot of things that don't float in their own liquid when they're solid. So why does it matter that ice would float in its own liquid? Well, if you had a pond right here and it did like other solutions or other liquids do, as soon as it makes ice up here on the top layer, then it would sink to the bottom. And really what would happen is it would freeze from the bottom up. So you would have like ice, and then this would sink and make another layer, and it would sink and make another layer. And before you know it, you have a pond that is completely and totally frozen from the bottom to the top. Now, does that matter to you? Kind of, if you like fish. Because if you had a fish out here in this pond, it would keep getting forced further and further up with the layers. And so thankfully, this is not how it happens. What actually happens is that water is its coldest and it's its most dense at 4 degrees Celsius. So once this top layer reaches 4 degrees, it'll sink. And the 4 degrees will go down to the bottom. So it'll be 4 degrees Celsius down here. And then the top layer can cool off and become 3 degrees. And then it can become 2 degrees. And then it can become 1 degree. And then before you know it, you have ice up here on the top of the pond or the lake. But you still have liquid water underneath it. And our fishy friend, I don't know how I do that. Our fish friend can live. He can swim because he's in liquid. So it is kind of important for living things that ice is able to float. Okay, we did this in our last lesson too, and I'm mentioning it again here, that you have this concept of like dissolves like. So what that means is that polar dissolves polar, and nonpolar dissolves nonpolar things. Water is considered to be the world's universal solvent because it can dissolve both polar and ionic compounds. Water is polar, and so therefore it will dissolve both of those. So that gives water a ton of things to be able to dissolve. So again, it's the most common thing that you and I come into contact with, and it's why when we reference our experiences, we think everything should behave like water, because water is in everything around us. Now, how you might see this on a final exam or on my test is something like this. If you're given this list of compounds and asked whether or not things would be soluble or insoluble with water, what you're going to have to do is look at them and go, well, is it polar or is it ionic? And both of these things are a throwback to Module 6 and Module 7. We reviewed all of it in Module 8. So you could go back to 3 if you're having trouble deciding if something is polar or ionic. Well, first of all, it's ionic if it has a metal at the front of it. So this has a metal at the beginning. So this would be soluble. And remember yesterday, or in the previous lesson, we said that you could use the words miscible and immiscible. This would be miscible with water. It would mix with water. So it would be soluble because it's an ionic compound. BF3. Well, BF3 is covalent. The first ingredient is a metalloid, which means it's going to be acting as a nonmetal. And so you might actually have to go all the way back to these modules to sit there and look at the shape of BF3. BF3 was triangular planar, which means that it is nonpolar. So this is insoluble in water because it's not polar. All right, KCl, it starts out with a K, that's a metal, so this is an ionic compound. It would be soluble. Now this one starts out with carbon, so we know it's going to be covalent. As far as is it polar or ionic, we didn't draw out anything that had this many carbons to it, or this many H's and O's and things like that. But so if that's the case, then just assume that it's nonpolar, which would make this particular one soluble. Okay, so you have some practice like that on your papers. The other thing that we discussed in the previous lesson that I have some practice for you today is how to write dissociation equations or ionization in water. Remember, to dissociate means to break apart. Again, this is what we did back in Module 9 when we did our net ionic equations. And, no, I take that back. Module 10 when we did net ionic equations. And we talked about chemical reactions. You had to break these things apart if they were aqueous. It's the same thing that we did back then. So if you were going to write the ionization of these, you would simply write it like this. Put an arrow, and then break them apart into the ions that make them up. There's a calcium ion and 2 chlorines. That 2 is going to go in front. Each calcium has a +2 charge, and each chlorine has a -1 charge. You can write the 1 or not, but you have to write the negative. Okay? N2O. This is a nonmetal. So what you would end up writing right here is does not ionize, or you could write does not dissociate, or no reaction. This doesn't break up. It can't break up because it's not an ionic compound. NaCl. Well, it is ionic. It's going to break up into a sodium ion and 1 chlorine ion. I didn't put a 2 this time because there's no subscript right there. Okay, Al2O3. Well, it's made up of aluminum and oxygen. There are 2 aluminums, so we put the 2 in the front. Each aluminum has a +3 charge using my periodic table. And then there are going to be 3 oxygens because of that 3. They each have a -2 charge. So you need to correctly be able to write the ionization equations or the dissociation equations for these. Okay, with that said, it's practice time. About the only skills that you have are those last couple of things with determining if something is soluble or insoluble and how to write the dissociation equations. Otherwise, work ahead if you would like to, and let me know during office hours if you have questions.